Now, today we are going to discuss Greens Theorem. Yes?
Yeah.
You know what is
Mhm.
Greens Theorem?
An easier way to find the area.
Find out the area.
It's-
I'll take a new slide. Insert. See, I'll mark a point here. I'm going to mark
Yeah.
it, and I'll call this as an origin. I'm going to call this as an origin. I'll call this as O. What is the point here? Suppose I want you to find out the length here. Suppose I take another point.
Yeah.
So, say 2 centimeter. This is O, and this is A.
Mhm.
And this is A. And another thing I will call it as B. Another
Yeah.
point I will call it as Control C, Control V. Now, suppose I go towards right hand side by 2 centimeter, right? Then already I am at 2 centimeter. Now I am going further by 2 centimeter. Now what is the distance of B from O?
4 centimeters.
4 centimeter. What have you done? You have added. That means you have taken a sign as positive sign, right?
Mhm.
Suppose I go from B to A by 2 centimeter. What is now the distance of A from O?
A from O is 2 centimeters.
2 centimeters. No.
Mhm.
I have gone from B to A.
Yeah.
And you know the distance between A to B is 2 centimeter. And
Yeah.
O to B is 4 centimeter. Now,
Yeah.
when I travel from B to A, and
Mhm.
now I'm asking you what is my distance from O, what is the answer? You said 2
You're
or
at A.
Yeah.
Yeah, you're at A, and then you go. The distance from A to O is 2.
OA is 2 centimeter. I'm not giving any dimensions. I'm not giving any signature, right?
Yeah.
And AB is 2 centimeter, right? I go from A to B. Now
Yeah.
I am at a distance of so many centimeters from O. Tell me what is the distance? See,
2.
what is this distance?
2.
What is this distance?
2.
No, what is this distance?
The total distance is 4.
Okay. I'm asking what is, I go from A to B. Now I am at a distance
Oh,
of,
okay. From A to B. All right. From B to A, then it would be 2. Yeah. Okay.
right. This is the question. Visual question is this. Now you have understood this question?
Yeah.
Visually, this is the question. So this is 4 centimeter. That means A to B have added. Now I am asking, again, I go from B to A. Now I am at a distance of so many centimeters from O. What is the answer?
If you go from B to A, then it's 2 centimeters.
Distance from O to A is 2 centimeter, right? What did I do? I subtracted.
Yeah.
Numerically, the question is OA is equal to what?
OA is equal to.
From A to B, if you go, you are adding plus 2.
Yeah.
From B to A, if you are going, you are subtracting, negative. So what is this you followed? That means you followed positive direction is towards right hand side. Negative direction is towards left hand side. Yes or no? No, you say no. You say yes or no.
Oh, yeah.
Now tell me this is positive or negative?
This is positive.
Very good. Now, this is a standardization we follow. If you do not follow this, you will never get any answer correctly. Okay? Understood? Now, tell me the area has got a signature or not. Area has no sign. What is the area? If I say that you say 2 centimeters squared, will you ever say minus 2 centimeters square? No. Area
no.
is always positive. Area is always square unit. Length into length is length square. A square is always positive. Square of a number is always positive, and therefore area is always positive, right? Okay. That is one way of looking at it. Now I'm going to tell you the area I will calculate. I will insert a rectangle. Now, I will also teach you one more basic. What is 2 into 2?
4.
2 into 2 is, oh God, I did not ask that. 2 into 2 into 2?
8.
Very good. And then I keep on multiplying say into 2 n times. Right? What is that? What is this?
That's 2 to the power n.
What is 2 plus 2?
4.
Plus 2?
6.
And then plus 2 n times?
2 times n.
Is equal to 2n.
Yeah.
Similarly here, I'll put equal to. And here it is. Don't tell me why did you teach me all these things later on, but I'm teaching you basics because this is required. This may be required anytime in this, right? At that time you should recollect, he said. So this is 2 power n. 2 into 2, 2 into 2 into 2 is 2 power 3. 2 into 2 into 2 into 2 4 times is. So if it is n times, it is 2 power n. If addition is n times means 2 into n. So addition is converted into multiplication. And multiplication n times is converted into power. Clear? Yeah, we are simplifying a number of additions into a multiplication. We are simplifying a number of multiplications into a power, exponential. Basic. Clear?
Yeah.
And that is what we do in integration. Yes or no? What we do here, we take a small length. And then what is the area? I will take this as y. Take this as y. What is the area here? Area is y delta x. Yes or no?
Yeah.
Now, suppose what is the total area here? Y into 4 times delta x. We are integrating. We are finding out the area by integrating it. Right?
Yeah.
We are finding out the area. A is equal to integral. But we are just adding. No? We are just adding by multiplying or by integrating. Integration is nothing but a sum. And sum is nothing but a multiplication. Yes or no?
Yeah.
I'll just put the limit. Y into dx. And from 0 to, here if it is 0, if it is 1, 0 to 1 we put. This is how we are integrating. Now we are integrating from left to right. Clear?
Yeah.
That if that is positive, if I am integrating from right to left, this will be negative. But the area has no signature. Right? But it will give you a negative value, minus 2 squared. But still, what should I do? I will change it to minus of minus because it has no signature. I'll make it as positive term. Understood? Okay. Therefore, if I am integrating from right, I will take a minus sign. Right?
Yeah.
Right? If I put A to B, I'll call this as A. I'll call this as B is equal to minus of B to A. Right? A to B integral y to dx, y dx is minus of integral B to A, y dx. We are not trying to calculate area. We are trying to calculate numbers and operations on numbers.
Yeah.
Okay. Keep this in mind and we'll go to Greens theorem. Integral u dx plus v dy is equal to double integral of dv by dx minus du by dy dx dy. Clear? This is what it says. Don't bother about what is uv and all. It's all a function, right? What function it is, we will come to know very clearly in a few minutes. You can also use p and q or q and p like this. This you will use it as dou q by dou x minus dou p by dou y. So p and q you can use. Instead of u, you can use p. Instead of v, you can use q. Okay? U and v are just p and q. What I will be using is p and q. In your class, they will be using only p and q. Yes or no? In your class, what they are using? P and Q or U and
P
V?
and Q. P and Q. So then it'd be P of QX and PY, yeah.
Here we are doing a calculation, just like no, we are converting the additions into multiplications and multiplications into power terms. We are doing the same way. We are simplifying by which is simple, this left hand side or right hand side?
Left hand side.
No, right hand side. Whenever you are doing
to integrate it, yeah, the right hand side is easier.
Whenever you are doing an integration, it is easy to add 2 and 3, or it is easy to add 2000 and 3000.
It's easier to add 2 and 3.
Yeah, this is what is you are differentiating and then integrating.
Yeah.
Therefore, this is right term, right? This is where smart comes, right? This is where you make a mark over the others, right?
Yeah.
Plus over the others only because you know it, because you know arcade. Right?
Yeah.
Now, Greens theorem is Stokes theorem, Gauss theorem. I think you must be having it, but we'll be using only Greens theorem now. This is what it is. What does this mean? I will tell you. Right? And this is the problem we did yesterday. So you would have mastered it. Right?
Yeah.
This is the problem we did. We are using Greens theorem we did. Now, Greens theorem is used for the integration of a line combined with a curved plane. It shows the relationship between a line integral and a surface integral. Do you understand the damn of it? You understand?
I understand how to use it.
What is it?
It's basically finding the integral of a curve.
What is this we are doing?
Under a conservative...
No, here what is this we are doing? What is this we are doing? We want to find out the arc length. Yes or no?
Yeah.
We can find out the arc length by integration.
Yeah.
We can find out the area also by integration. Yes or no? And we can find out the length from the area also. There are various methods, right? So when you are doing an operation, by doing a different operation also, you can get at the same answer. That is what we are doing now. Later on, we'll be using it for what you say, for finding out the area, for finding out the perimeter, whatever you want, right? All complicated things, we'll be using it only if you are smart. But for the present, we are only dealing with numbers, how to get the same number using different operations, either by operating on the number or operating on the area. Okay?
Yeah.
So when I say this thing, see, suppose I take this point and take this length. Force, I take a force is acting on it and I take a small distance. So force into distance. Yes or no?
Yeah.
That is work done. Force into distance is work done. That is a scalar value. No direction, no sign.
Yeah.
Always
but then
positive.
If the curve is like a closed conservative curve, then it's zero.
Then, yes. Now, from here to here, I take another. Again, work is done. Again, no signature. Positive. Again, work is done. No signature. Positive. So I keep on finding out total work done, some value. I do some operations and get it a value. Suppose I do it from here to here. What I will do? I will just do the same thing, subtract from this one by one. This is what you call it as a potential. You have got some value here. You arrive at a value which will be added. Right? Understand? It is like if you keep it at a particular height, what is the potential mgh? If it comes down, what is the potential here? Here, same potential in kinetic form. Yes or no? Here mgh, here md squared by 2. Both are same. Similarly, we can calculate either by potential or by kinetic form. So we are now dealing with potential here. Now, I will come back to the Greens theorem. There are two methods of proof. I will give you one method today. Probably I'll give you the other method tomorrow. If time permits, I'll tell you, but I don't think that I'll get time. This is not such a big proof, but anyway, I will try to tell you.
Is this the proof for Greens theorem?
Yes, but I'm not going to teach you so much. Don't worry. Don't be afraid.
We have to write this on the test.
You have to write it on
the test.
Okay, then what I will do is I'm going to teach you this method, which is going to be very simple. Right? This method is okay for you now. Let me not frighten you by this, but this is so tedious. I'm going to use only whatever I taught you so far in deriving that Greens theorem. If P and Q are two functions having continuous first order partial derivatives, do you understand the meaning of this?
Yeah. P and Q are two functions that have continuous...
P and Q are two functions. How do we get these functions? I told you U and V, and what is that U and V? We will come to know it a little later. And with respect to X and Y, in a region E, that is any region in XY region, right? On a plane, bounded by a closed curve C.
Yeah.
This is a line, and this is a closed line, right? This is a curve, and this is a closed curve. So we are saying closed curve. So you understood the meaning of that?
Yeah.
I'll erase this. Now, this is a curve, right? Now, this is a closed curve. I have split this into two parts. The curve is, I have taken a point at the bottom. I have taken a point at the bottom curve. I have taken a point at the top curve. It is a closed curve. So that I can refer this A, P, B, Q, A, which is a closed curve, right? And normally when I do an integration, either line integration or area integration or double integration, we go from left to right because that is positive. Okay? Yeah? And then this is what this Green theorem says. What is stated here is put it in the mathematical form here. This is a curve. I say closed curve. P dx plus Q dy is equal to double integral over a region E, dou Q by dou x minus dou P by dou x. Sorry. Dou Q by dou x and dou P by dou y, right? I'll make this. This is correct. We'll try to explain this, right? Clear? This is what the theorem says, right? Integral P dx plus integral Q dy. P dx plus Q dy integral is equal to double integral dou Q by dou x minus dou P by dou y dx dy. Right? I take this function here, this point, and this is going to have a function. This is going to have another function. The curve BQA is going to have a different function because for any x value, value is different. Yes or no?
Yeah.
Therefore, it will be a different function. I call it as a f2x, and this I'll call it as y is equal to f1x. And y is a function of x. Y is a function of x, right? Integrating a function f of xy on the region, this is what we are saying, right? Okay. We are integrating a function over this region. What is this? Integral x is equal to a to b. This I'll call it as b. Integral a to b. And another integral f1x to f2y. Because I have to integrate with respect to x and y, double integral, right? This you might have studied in my multiple integral or go through my video.
Yeah.
Yes or no? I have taught you, no?
Yeah.
Vertical strip integration. We are doing a vertical strip integrations. We are finding out this height y for each and every strip, and then we are going to do it. F of xy dy dx. First integral with respect to y. Y is varying from the a to b. It is varying as a function of f1x. And then it is varying as a function of f2x. So this fxy has got two different functions. One from a to b and another from b to a. Is it clear?
Yeah.
Okay. Now here is, I am showing this visualization in two ways. Here I am splitting this closed curve into two parts, top and bottom, right? So integrating a function f of xy on this region APBQA in this way and in this way. Here I am splitting into two parts, left part and right part. Here the limits is in the y direction, here the limits is in the x direction. That is constant limits in the x direction, constant limits in the y direction. So integral x is equal to a to b, integral y is equal to f1x to f2x, f of xy dy dx is same as integral y is equal to c to d, integral g1y to g2y, f of xy dx dy. Now we will take the right hand side of the Greens theorem and then prove that this is equal to left hand side integral p dx plus q dy. So we will take this one by one. We know integral of a differential of a function is the function itself. So here I am taking integral of differential of function q is equal to q with the limits g1y to g2y. Here again integral of differential of p is nothing but this p with the limits f1x to f2x. Right? So double integral over the region E dou q by dou x minus dou p by dou y dx dy is equal to, in this way, integral y is equal to c to d qxy g1y to g2y limits dy minus, in this way, integral x is equal to a to b p of xy with limits f1x to f2x dx. Right? Therefore right hand side we have brought it in this form. Right? So you can now see this, refer these two. And this is equal to integral y is equal to c to do, and then I am putting the limits q of g2y minus q of g1y dy minus, here again I am putting the limits integral x is equal to a to b p of f2x minus p of f1x dx. Now we will see these two terms separately now. For these first two terms, g2y is here, g1y is here, right? And integral y is equal to c to d. That is what we are taking. And that is equal to pbq, because first term is pbq because limits are c to d, no? So c to d, therefore pbq for g2y, and then here it is paq, right? Now I can change the sign and make it is qap. so that the integral will be continuous along PBQA. And similarly here, we will see here f2 of x is on the top and the limit being from x is equal to a to b, AQB. This is AQB and minus of this. So now I can change this to BQA and change the sign to plus. And here it is minus of minus is already plus. And here f1 of x, here APB, because x is equal to a to b, therefore it is going along APB. Therefore here BQA PB. So continuously going. So that I'll make this change here plus sign. Here also I'll make this sign here change to plus sign. And you will get PBQ AP, BQA PB. Therefore both are anti-clockwise, so that we can integrate it and add it as it is here. And what is this? This is nothing but cyclic integral of PBQAP, and this is nothing but cyclic integral of this thing. And separately if you take it, integral PBQAP Q of xy dy plus integral of BQAPB P of dx. This is nothing but left hand side. Therefore integral cyclic integral P dx plus Q dy is equal to double integral dou q by dou x minus dou p by dou y dx dy. This is what is Greens theorem, and it is proved.
Yeah.
That's all.
Nice. I think I got that down in one page.
Yes.
Thank you. Bye-bye.